Chapter 12, the field effects transistor. In this we will generate the drain curves for this transistor. The function of the transistor is simply like a bipolar transistor, but the small difference is it has three terminals called a drain, source, and a gate. And with the help of the controlling the gate, we control the amount of current passing through the source to the drain. It's like a tap action. Now it has three pins, so there is a p-type of substrate between the two n channels, and all the metal contacts are taken from the SiO2 layer between them. We apply a voltage between the gate to the source, which controls formation of the channel between the p-type of substrate and two n channels. So controlling the voltage applied to the V at the gate and source, we control the current passing from source to the drain. Now this is the graph for the various voltage applied between gate and a source. At the lower it is at the channel is off, so there is no current passing through that. When we increase the VGS to VGS equals, we enter into region of saturation, and there is other region of linear region where the output drain source is proportional to VGS minus VPS. So we have the drain current directly proportional to the VGS in the linear region. So as we decrease the VGS, the channel is off. With a little bit increase, we enter saturation region. After that, the variable test circuit is like that. We form a V control at the gate, and we use the variable resistor for minus 2.3 like that. So this is all parameter setting for the V control variable for 2.4, 2.8, 2.9, 2.4. That's all we have. Now this is the graph we obtained with the variable resistance curve, and that's the red one is the IJ2 and green one is IJ2. This is the primary DC sweep in the VDD, and secondary sweep is the V control. Now advanced activity for the FET. We're gonna generate the graphs. Now in the schematic, make a new tab, advanced activity. Now we will analyze the FET transistor. Add the voltage. For the biasing we need VDD, VDS and VS. These are all the voltages we give. Give the JFET. This is all the components with the JFET. We have to make a proper distance so that we can make the graph properly. Now we need to make all this component. Take care. Change the names, place the grounds, giving the values. That's all the grounding to the we're gonna give to the base biasing circuits. That's the grounding for the source. This will supply B as like source so that we can give to the gate circuit. So these are the things we confirm that our connection is right. Now we're gonna make a connection between these two. So this will show the connection is right or wrong. We are connected to the gate. That's okay. A circuit to the gate on JFET. Now this is the circuit. VDD. Now change the names of the parameter. Give this number as RGG. We're gonna make that's the 10 volt DC. That's VDD. Now we want to have a V control. This is V control. This will be the V control voltage of 2 volts, but we have a variable list of minus 2.5, 2.8, 2.9, 2.94, 2.94. So this will be the controlling voltage we give to as a parameter in a simulation so that we can trace the family of curves. Now over here VDD2, that's starting value we're changing, ending values. This is the variable list we give: 2.4, 2.8, 2.9, 2.94 and 2.96. So this will be the voltage given to the gate. Run the simulation. This goes to the gate. So the VDD2 is our X parameter. For various value of the VDD, we will generate a graph. That's VDD, and that's various values of I's. This one is the I's, and this one is IJ2 at D for various value of gate current.